So let's do question number 2. Question number 2 reads, contracts awarded have been classified as education, health, community, or others. Are the average values of these contracts the same, or are there any differences among the 4 groups? And let's go to the raw data to see how we can answer this question. The 2 variables that are of importance is the contract type and the contract value. This is what we will use to answer this question. The contract type is a nominal categorical variable. It's got 4 categories: the community, school, other, and hospital. And this is in no order. That's why it's called nominal. If it's in order, if it must be read in a certain order, then we call it ordinal categorical variable. The second variable of interest is the contract value, which is a continuous variable because it's in PNG Kina. Okay, so here we are trying to find if there are any differences in the mean contract value of each category of the contract type. So in the contract type we have 4 categories, and this will split up the contract value data into 4 categories of continuous data, right? And when we have more than 2 categories of continuous data and we want to compare the mean against each other, the test of significance that we will use is a one-way ANOVA, or one-way analysis of variance. So we are going to use one-way ANOVA to answer this question. Now, what I like to do before we answer this question is to extract the 2 variables that are of interest onto a new worksheet. So I'm just going to copy both these variables and then paste it in sheet 2. Okay. Now, we've got this in sheet 2, and the first thing that I like to do is to get a feel of this data, to understand certain characteristics of this data. The contract value. So I'm going to do a descriptive statistical analysis of this. So let's go to data, go to data analysis. Going to go to descriptive stats, click OK. For the input range, we'll select the contract value. Going to get a descriptive statistical analysis of that continuous variable. We'll use labels in the first row. I'm going to output, I want it somewhere near. So I think I'll put it there. Okay. And I'm going to take summary statistic. We can take confidence interval and all that, but there's no need to do that now. And I'm going to click OK. There we have an output of the descriptive statistics of the contract value. Now I'm just going to put borders around the cells to demarcate each cell. Now we can see that the mean is 128,000 and the median is 129,000. So the mean and the median are almost the same. This implies that the distribution of the data follows a normal distribution pattern. Okay? And you can confirm this by looking at the skewness. The skewness is 0.2. A skewness of 0 implies no skewness, either to the left or to the right. One that is 0.2 is so minimal that we can safely conclude that this data is normally distributed. So you have to remember the 3 assumptions of a one-way analysis of variance. First is that the data should be randomly selected. and we have been assured in the question that it was. The second is that the variance of each category should be the same. And there's a test called Ballard's test that they do. We won't do that now. To confirm that, we're going to assume that the variance is the same. And the third assumption is that the data should follow a normal distribution pattern. And we can confirm that by looking at the mean and median, which are almost the same. Okay, once we got that, now we have a fair understanding of what our data looks like. We can go and calculate the one-way ANOVA. Now, it is very difficult for Excel to calculate the analysis of variance when the data is organized like this. So you have to help Excel out. And I'm going to reorganize this data by putting them into 4 columns according to the contract type. So I'll type community here. It's going to create the 4 columns. School, this is the column of contract type. Hospital and others. Okay. And what I'm going to do now is sort these 2 variables from the smallest contract value to the largest according to the groups. So we select that, and then we go to sort, and we'll click custom sort. Okay. Sort this sort by will select contract type, okay? And then we'll sort on the cell values, and we'll sort in the order A to Z. So if we click OK, you can see Excel arranges the contract values and lines them up according to the community, hospital, other, and school categories. Now I'm just going to copy the contract values for the category community and paste them here. Okay. Just copy the values. I'm going to do that for hospital as well. Just only the hospital. Okay. Copy. Paste the numbers here. Paste only numbers. And then I'm going to copy for others. Okay. Now paste them in the others column. And then I'm going to copy for the hospital. Just the final one. And we'll paste it in the hospital column. Okay. Now we got that. I always have the urge to demarcate and border just to make it look nice. So here we have it. Now we've separated them into 4 categories, and this looks good. Now we are going to calculate the one-way ANOVA. So the one-way ANOVA, as I said, will compare the means of more than 2 categories of continuous data. Before we do that, we have to state a hypothesis. The null hypothesis states that there is no difference in the mean contract values of each of the 4 groups of the contract type. That is, the mean of community is equal to the mean of the contract value of school, which is equal to mean of the contract value of hospital, which is equal to the mean of the contract value of other projects. The alternate hypothesis is that the mean contract values of at least one of the 4 groups are not equal to the others. Okay? Now that we've stated the hypothesis, let's go in and calculate the one-way analysis of variance. We'll go to data, click data analysis, and we will click ANOVA single factor. Okay. Click OK. For the input range, we will select the new columns that we've created. Okay. We'll group by columns because the categories are in column. And then we'll click labels in the first row. We'll leave the alpha error at 0.05 since this is the widely accepted alpha error. And we'll have the output. I want it to be in the same worksheet. So we'll have the output here. And then, okay, so here we have the ANOVA output. We have two tables here, the summary table and the ANOVA table. In the summary table, we have the four categories: community, school, hospital, and others. Is the four categories of our contract types. And then we have the frequency or the count in each category, the sum of the total contract value in each category, the average of that contract values in each category, and the variance in each category. The second table, we see the ANOVA output, which contains the source variation between groups and within groups, and it's between groups that we're interested in. The sum of squares, the degree of freedom, the mean squares, the F statistic, probability value, and the F critical statistic. Now, these three values is what we are interested in. So I'm going to highlight them there. So how do we interpret this? You can see that the F statistic 0.25 is much less than the F critical statistic of 2.7. And therefore, this would imply that the p-value is actually greater than 0.05. And so the actual p-value is 0.86. When the p-value is greater than 0.05, we accept the null hypothesis that there is no difference in the mean of the contract values between these four groups. Okay? So the final conclusion, or how I would state this, is that at a p-value of 0.86, there is no statistically significant difference between the mean contract values of each of the four groups of the contract type in the survey. So here we will accept the null hypothesis. Now, in the event that the calculated p-value was less than 0.05, and we rejected the null hypothesis and accepted the alternate hypothesis, we would proceed further and do a post hoc analysis, or what we've learned as the Turkey-Kramer test, to identify which group or groups of a contract value mean is significantly different from the other contract value means. And that's about it for question 2. I hope this helps.